Every star you see in the night sky was once nothing more than cold dust. Silent clouds drifting through space for millions of years. But somehow, these quiet clouds create stars. Giant spheres of fire, powerful enough to outshine entire planets. So how does the universe turn dust into a star? Let's watch a star being born. Every star begins inside enormous clouds called nebulae. These clouds are made mostly of hydrogen, the simplest element in the universe, mixed with tiny grains of cosmic dust floating quietly through space. Some nebulae stretch across hundreds of light years. Yet despite their enormous size, they are incredibly thin. So thin that they almost seem empty. For millions of years, nothing appears to happen, until gravity slowly begins pulling gas together. Tiny changes start growing, bit by bit, and eventually, the cloud begins to collapse. As the gas collapses, the center becomes denser and hotter. Gravity keeps pulling more and more material inward. The entire cloud slowly starts spinning, forming a huge swirling disk of gas and dust. At the center, a glowing object appears, a baby star. Astronomers call it a protostar. It's not a real star yet, but it's getting close. Gas keeps falling into the center, feeding the growing core. The protostar becomes heavier and hotter. Pressure inside the core rises dramatically, and the temperature begins to skyrocket. Deep inside the core, hydrogen atoms begin colliding, crushed together under extreme pressure. And then, something extraordinary happens. Hydrogen atoms fuse together, forming helium. This process is called nuclear fusion, and it releases enormous amounts of energy. For a moment, everything is about to change. Suddenly, the star ignites. A new star is born, and it begins shining across space. Gravity still tries to crush the star inward, but fusion pushes outward with incredible force. Two powerful forces locked in constant battle. When they finally balance each other, the star becomes stable. Now the star enters the longest stage of its life, burning hydrogen into helium, producing energy for billions of years. But not all stars are the same. Small stars burn slowly and glow faint red. They can survive for trillions of years. Massive stars burn extremely fast. Some live only a few million years. The bigger the star, the shorter its life. Size determines destiny in the universe. And stars rarely form alone. They're usually born in clusters. Hundreds, sometimes thousands at once. Inside giant stellar nurseries, lighting up the surrounding nebula. Around young stars, disks of dust still remain. Inside these disks, new worlds begin forming. Dust particles collide and stick together. Growing slowly into rocks, then mountains of stone. Eventually, forming entire planets. This is how solar systems are born. Our own sun formed this way. About 4.6 billion years ago. The leftover material became planets, including our home, Earth. A small rocky world orbiting a young star. Bathed in its light. Powered by its energy. But across the universe, this process never stops. Clouds collapse. Stars ignite. Galaxies slowly fill with light. Again and again. For billions of years. Every star has a beginning. Even the sun above us. Born from dust. Shaped by gravity. And given life. By time.